Hello everyone. Um, Today, the topic that I'm going to discuss is curvature. Actually, I have one small feeling about this topic. First thing is that many students are scared to attempt questions on this topic. At the same time, for the teacher in the marathon to finish the syllabus for the semester, proper justice is not being done in the classroom. Even if students are ready to listen, teacher doesn't get enough time to justify this topic, because of which I'm doing it separately on an online platform so that it is available for all those who are interested to learn the theory behind how we get the formulae for radius of curvature, center of curvature, and different things. Okay. Yeah. First, coming to the terminology, the word curvature, we can clearly see in the curves A, B, C, and D. First curve is a line, and then B is a little bit bent curve. Of course, C is a little more bent, and D is much bent. Okay. By the way, actually, the plain definition of curvature goes like how much we are trying to assess how much a curve is bent. Okay, mathematically we are going to assess, and then the basic idea behind the formulae for radius of curvature would be just the Pythagoras theorem, the basic Pythagoras theorem, which about students are all aware, guys. Okay, it's not a rocket science, it's just the Pythagoras theorem. Let's see, let's build the concept and then talk about how things come up with Pythagoras theorem. Suppose if y is equal to f of x is my curve defined in an interval I. I'm considering a curve in a specific interval I. Okay, and let A be a fixed point on the curve, and then P be another point on the curve. P and Q both are two different points on the curve. Okay, yeah. P and Q be two different points on the curve. The basic idea is that we go from A, P, and then go to Q. Okay, actually, the basic idea is like that. Why? Because we can clearly see at P, the curve is bent. So how much it is bent to assess that we are moving from P to Q. That's the basic idea. P be another point on the curve and Q is a third point on the curve, a little nearer to P. Why? Because you will understand. Just see the length of the arc. If I try to write the length of the arc in terms of the units, the arc AB, if I assume that the arc length AP, I'm sorry, AP is equal to S units, and then AQ, the total arc under consideration, AQ, if I take S plus delta S units, if I take, obviously it is clear. You will be able to tell what would be the length of PQ, because that's the remaining part in the arc. Okay. Arc length of PQ would be delta S units, right? Okay. Yes. Now, again, what I will do is, since I'm considering 2 points moving from P to Q, I will just assume that the tangented point P is making an angle xi with the positive x-axis, and then the tangent at point Q is making an angle xi plus delta xi. Okay. Yes. So next, what we will do is, we will just try to assess the total bending of the curve. Okay, what exactly is our motive here is the total bending of the curve, the total bending of the arc PQ can also be called as total curvature. Total curvature. Curvature is basically how much a curve is bent or an arc, because I am considering arc here. Okay. Yeah. Now the total bending of the arc PQ, the total curvature is nothing, is defined, how much it is bent will it be defined by the angle, delta xi. Why? Because the variation from P to Q, there's a change in the angle of delta xi. Clearly we can observe that little change, whatever is there. Okay. Yes. The average curvature of arc PQ would be, the ratio between would be ratio between, I'm sorry, ratio between delta xi and delta s. Delta xi and delta s. As we all know, as we shift from P to Q, as we shift from P to Q, the rate of change, if I put, see, I will just rewrite it like this. That is limit Q tending to P delta xi by delta s. This is nothing but as I move from Q to P, what would happen? This delta s, whatever is there, that goes to 0. Yes or no? Right? When I move from the point P to Q, P and Q coincide. So there's no that extra delta s term. Okay? So what happens? I can rewrite this as a limit delta s tending to 0. Yes? Then delta xi by delta s. Yes, this is nothing but, I can clearly see this is nothing but my classical definition of a derivative, right? So I will rewrite this as d xi by ds. Agreed, guys? Agreed? Yes. Now, d xi by ds, and this thing would be denoted by, now denote xi. This xi is equal to, I'm sorry, not dou, it is d xi by ds. It is d xi by ds. Okay, right. Now, this is the that xi, chi or whatever. Okay, you can call this chi. Okay, if you're comfortable, you can call this chi. And now the reciprocal of chi would give me the radius of curvature. Radius would be denoted by rho, and then it is nothing but the reciprocal of chi, guys. And then how we come to this again, I will do it in a different video. I mean, about Pythagoras theorem I was talking, that I will talk about in a different video. Here I will stop it. I think this much is clear to all of you. Okay.